Welcome to this session of continuation of operators in C. In this session, we'll learn about assignment and comma operators and bitwise operators. Assignment operator is the least precedence operator in C program language. So what does it do essentially is it takes the right side value of an expression or a value and assigns it to the left side variable. So in an assignment, there is an expression, there is a left side variable, right side an expression or another value. What happens is that the right side expression is evaluated, the value is assigned to the variable identified on the left. In mathematics, it is permitted to have expressions on both sides of the equal to sign, but in programming languages, it is not permitted. Left side should have only variables. So what does it do? Assigns value of the right side expression to the variable on the left side. And the assignment operator has the lowest precedence. Right? And its associativity is right to left. Right side value is assigned to the left side value. Example we can see here, x is equal to y is shown here. Right? And there is another operator called comma operator, which is used to separate different expressions or different variables. At the time of declaration of variables in the programming language, multiple variables can be separated by comma, but they should belong to same data type, homogeneous data types. For example, when I want to declare 4 variables of integer type, I can write int x, y, z, a. I can also write int x, y, z is equal to 25. I am initializing the value there. It is not assignment. When value is given at the time of declaration, it is called as initialization. But I cannot write int x is equal to 25, float y is equal to 35.5. Two different data types are there. Comma is not used to separate different data types variables. Comma can also be used to separate two expressions. For example, x is equal to a plus b, y is equal to c plus d is permitted. So expressions can be separated and homogeneous variables can be separated. Again, this also has least precedence. That's what we see here, right? Associativity is left to right. We'll not do any example programs because these are too small to spend the time. We will learn about this as we do other programs, right? Through bitwise program, other subsequent programs also we'll try to learn. Fine. So we'll go to the next topic, bitwise operators. What we said about assignment and comma operators that they have the least precedence is equal to sign. Single equal to is used for assignment operator. Double equal to is a relational operator. So as we discussed in the earlier session, single assignment or equal to should not be confused with double equal to. That is a comparison operator, equality operator. This is assignment operator. Now we'll go to bitwise operators. So what are these bitwise operators? So far we have discussed all the operators which used to work on word size, but certain features in the programming language are preferred where each bit can be operated individually and the result taken for decision making purposes. Bitwise operations do not have actually a numerical value attached to them. Bitwise operations are taken with each bit operated by corresponding bit or some other bit, and the result is taken for decision making purposes or controlling purposes. That's the significance of bitwise operators. It is called, it is predominantly used in low level programming because the programmer is coming down to the level of machine and operating at the bit level, right? Now, they facilitate manipulation of individual bits within a word of memory. There are three general categories of operators defined in C. First one is one's complement operator. This one's complement operator actually bitwise complements the input given. Suppose input is given 1, then the output of this complement operation will be 0. How is it represented bitwise? The tilde symbol is used for representing the negation operation, bitwise negation operation or complement operation. Where do you find this tilde symbol on our keyboard? It is below the escape on the top, and it is like approximately equal to symbol that we use in mathematics. It's called as tilde symbol. Next, logical bitwise operators are there. Second category is logical bitwise operator. Third category is shift operators. Logical bitwise operators operate on each bit. What are the logical operations? And, or, exclusive or. There are three logical operators defined in C. AND operator. An AND operator gives output true only if both the bits in the corresponding position are true. Otherwise, it will be 0, which means that AND gate will give output only and if only if both the input bits are 1, otherwise 0. Logical OR operation is another operation which works on minimum high or minimum 1 enabled situation. It means that the output shall be 1 if at least one of the input bits is 1. It need not be that both are required. At least one of them is to be 1. For example, if one bit is 0, other bit is 0, output is 0. If one bit is 0, the other bit is 1, is 1. 1 and 0, 1. 1 and 1, 1. So we see that logical operator requires at least one input to be enabled so that the output comes. On the other hand, AND gate requires all the inputs to be 1, both the inputs to be 1. We are talking at the bitwise level. An exclusive OR gate is another circuit or another logic gate which operates on the principle that the output shall be 1 if and only if only one of them, one of the input bits is 1. It is called as inequality operator or odd gate. When odd number of inputs are 1, output will be 1. For example, let us take 2-bit input. 0, 0, output will be 0. 0, 1, output will be 1. 1, 0, output will be 1. 1, 1, since both are there, the output shall be 0 if both the inputs are same. So for even number of inputs, it does not work. For odd number of inputs, it works. That's why it is called as odd gate also, exclusive OR gate. Now coming to the shift operations, there are two operations defined, left shift and right shift. What happens is that when a word is given, when a memory word is given, data is given, left shift inserts 0 from the right hand and drives out the most significant bit in the memory location. So if I have 1, 0, a 0 shift left by 1 bit position will result in this 0 being driven to the higher position and 1 being deleted or lost. 0 will be inserted. So what we say is that 10 equivalent to decimal 2 when left shifted has become, one has gone to higher position, it gets doubled. On the other hand, right shift is the one which performs shifting one bit to the right, or number gets halved because shifting by one bit happens. 0 will be inserted from the most significant bit position, and least significant data will be, item will be last, bit will be last. Now, the shift operation takes two operands. One, the operator on which operation is to be performed, and the second one, the number of shifts that is required. The symbol that is used is greater than and less than symbol. Greater than, double greater than will show, will shift to right side. Double less than will shift to the left side by the number of bits. We will see the syntax of each of this. Now, the first one's complement. It is a unary operator, so it has highest precedence. Its symbol is tilde, and it causes bits of the operand to be inverted from 1 to 0, 0 to 1. If 1 is there, it will be converted to 0. If 0, it will be inverted to 1. Operator always precedes operands, right? By the operand. Operand must be an unsigned integer quantity. All the bitwise operators work on unsigned quantities. Doesn't matter, they are decimal, hexadecimal, or octal. Mostly what is done is, programmers, since operate at the lowest level, they don't get the complication of, or they don't want the roundabout way of declaring in decimal and being converted into octal or hexadecimal or binary. They directly handle at the octal or hexadecimal level. As a convention, what is done is that for bitwise operators, the variables values are assigned as unsigned, normally, or in the most recommended way, octal or hexadecimal, but it is not compulsory. We'll see some of the programs, how to manipulate them, right? For example, we will take a program now. We'll go to the program. We'll see how negation operation works. Negation are also called as bit invert operator, right? Here we have declared unsigned int x is equal to 25. P and Q are the variables we have taken here. We'll remove Q here. We'll put Q here with the octal. I am showing this program with decimal, octal, as well as hexadecimal. Recollect, how do we declare decimal variables? By way of just int and assigning them. And when we give value for the octal, we declare in a similar fashion as unsigned int y is equal to, but while giving values, 0 is preceded. If 0 is preceded, it is octal. And how about hexadecimal? It is always preceded by two alphabets, 0 and x. This indicates to the compiler that the what follows is actually hexadecimal number. So we will see negation in all the number formats, right? Right now, we will not have this statement, but I'll come to this statement before going to the next program. Now, I have assigned values here only, right? Rather than taking from the keyboard, because I want to see the result. Bitwise operation, there is no point in taking, or it's not necessary essentially. So what we have written, see this statement here, P is equal to inversion of X. This inversion, you can see it is tilde symbol, which is below the escape key, above the tab, that is between left tab key and escape key on the keyboard, and we have to operate with shift operation. Shift this key, tilde key will give us this symbol. Now what has happened? This command takes x as the value which is 25 and it negates it. That means 25 gets negated. Now, what is the meaning of negation? 1 becoming 0, 0 becoming, this is called as 1's complement. In decimal number system, there is 9's complement. That means each digit is subtracted from 9, it becomes the complement value of that number, right? Each digit is subtracted from 9 to get its complement value in that number system. In any number system, there will be r minus 1 complement, r's complement. For example, in decimal, r is 10. So 10 minus 1, 9's complement. That means subtract each digit from 9. The other is 10's complement. Perform 9's complement and add 1 to it, it becomes 10's complement. Now, we'll take this example. 25 is our number. What is 9's complement of it in decimal? 25 is to be subtracted from 99, each digit, right? 9 minus 5, 4. 9 minus 2, 7. So, for 25, the complement of 25 in decimal number system is 74. Similarly, for binary, since it is happening in binary, I have given decimal number system here. This should be converted to decimal number system. We'll see in a slide, right? And that decimal is to be complemented. Let us assume that it is 2-digit number only. That means the computer memory capacity is 2-digit only. Now, to find the complement, what is to be done? It is to be subtracted from 99 if it is decimal. So 99 minus 25, 74 will be complement. I should get 74. For 25, what do I get here? That means I have to convert this decimal number into binary and then look for the size of the memory allocated for the data type. That's where this comment, this statement size of comes. I want to know in this computer how much memory is allocated for integer data type, unsigned integer data type. We learned in the data types that the memory allocated is 2 bytes or 4 bytes. In my computer, it is 4 bytes. So my 25 is converted into equivalent of storage into 4 bytes of memory. And then it is complemented. How it is done, we'll see in the slide. Next, similarly, if it is octal, when I am giving octal, then I have to convert the decimal octal number into bit representation binary, then write it, its complement. For octal, see, for decimal number system, we are subtracting from 9 or 10. For octal number system, it will be 7777. 7 is the largest digit, right? 7 is the largest digit, and for decimal number system, 9 is the largest digit. For octal number system, it is 7. Octal means 8. 8 minus 1, 7. Similarly, for hexadecimal, 16 minus 1, 15. So each digit is to be subtracted from 9 in case of decimal, 7 in case of octal, and 15 in case of hexadecimal. That's what we see. Now you see the statement here. Decimal equivalent of the largest number that can be stored in hexadecimal is with 4 bytes, right? F. This is 1 byte. 2Fs is 1 byte here. Like that, 4 bytes are there, right? Can show 1 byte, 2 bytes, 3 bytes. You can see this is 1 byte, 1 byte, 1 byte, 1 byte. And what is its decimal equivalent? I have converted for your convenience into decimal equivalent. Decimal to hexadecimal conversion is another arithmetic altogether. Let us not spend more time on that. Let us not spend time on that. It is not required for us. So it is 4294967295. Now to get the complement in decimal, what I have to do is I have to subtract from all f's are equivalent of decimal. Now from 4294967295, when I subtract 20, what should be the answer? I should get from 95, 20 is deducted 70. So 4294967270 should be the answer for me. Am I clear? Let me repeat. The largest number with 4 bytes that can be stored at hexadecimal level is FF. When I convert this hexadecimal equivalent decimal number, then I get 4294967295. I have to perform negation or complement. That means I have to subtract this number 25 from this number. So I get 4294967270 as the answer. Let us see, we'll get or not. Similarly, for octal also, the octal equivalent of FFF is 3 followed by 10 sevens. 3 followed by 10 sevens. This is octal number system. Now, to find the complement from this 3 10 sevens chain of number, I have to subtract 55474. I will get octal equivalent. That means complement operation or negation operation. In hexadecimal, 0x, 5b3c is to be subtracted from FFFF. This is how we do it, right? Hexadecimal, hexadecimal number is to be directly subtracted. For octal, hexadecimal capacity is converted to octal equivalent. From that, octal number is subtracted. Similarly, for decimal, the FFFFFFF, the largest capacity, the largest number that can be stored is converted to decimal equivalent. From that, the decimal value is subtracted. We'll get the answer. Now, we will see whether we get the answer. This is what I have done here. So, P is equal to X. X is decimal. So, it is to be subtracted from P should get the result of 4294 blah 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 minus 25. Last two digits should be 70. Next, Q is octal and R is hexadecimal. Let us run this program. What I have written is printf. Printf, the negated value of, I have put %u here. Why %u? Why %u? Because we have declared unsigned integer. Bitwise operators work on unsigned integers, right? It is always good. Not that I cannot declare integers. I can, but there is no point in giving unsigned integers because in the internal architecture of the computer, everything is converted into positive number. Even negative numbers are represented in complement form. So it's a waste of memory space when we declare integer. Remember, when we declare integer data type, half of the memory is lost to store the negative number, remaining for positive. So it is no use. It is of no use. So what we do is we use unsigned here. Next. So shall we run this program? So for decimal, before that, for decimal, I have used %u. For octal, %o. For octal, I have to use %o. Even in scanf also you can see I have given. No, in this we have not used scanf here. We'll use it elsewhere and demonstrate. Here I have taken values inside the program itself, right? And this is for octal. Remember, in printf for octal, O is to be used. Doesn't matter whether it is lowercase or uppercase. Lastly, for hexadecimal values, it is X that is used. Capital X or small x, doesn't matter. So not of z or complement of z is equal to %x of /n, and see the arguments are given. This z will be for this value. Here %x will be replaced by this z, and this %x will be replaced by this negative z, complement z. We'll discuss about this printf statement in the subsequent topic after this topic is over. Now I will run this program. Now I will share this output screen for a moment. Maximize the screen and then come here. Share the screen, the output screen of my C program. Okay, this one. You can see here the negated value of 25 is 4294967270. We are interested in last two digits 7270, right? 95 minus 25 is 70. Similarly, the negated value of 55474, this was octal, is 3 all sevens 303 2303 lastly, right? Next, the hexadecimal value of negated value 5B3C we had given, it is FFFF. Now you can see, we'll directly understand here. 5 is, each digit wise we'll see. First, 5 is there, 15 minus 5, 10. It is represented as A in hexadecimal. We have A here in the fourth position from right. And B is actually 11. 15 minus 11 is 4. Correspondingly, we have 4 here. And 15 minus 3 in the tens position in the given number, right? 15 minus 3 is 12. 12 is C. We have C here. Lastly, C is the units digit. Again, 15 minus 12 is 3 now. We have 3 here. You can see for 3, the output is C. For C, it is 3. This is what proves that it is complement that is working. This is negation operation. It has happened on a bitwise basis, right? Though machine implements in binary, we are getting output in the format we have given. First one, we have used %u for decimal. Second one, %o for octal. Third one, %x for hexadecimal. If we use %d for all of them, we'll get the answer in decimal. If we use octal, we'll get all answers in octal only. So this is how the negation operation works. Now we'll go to another concept. We'll see that numerical example, how it has done, how the compiler has done through a PowerPoint slide. Now, logical operators. Logical AND operator. It returns 1 if both the bits have a value of 1 or true value. That's what we said. AND gate functions and gives output 1 if and only if both the inputs are 1. Logical OR operator. Minimal gate. At least one input should be 1. If at least one input is 1, then it will work. It takes 2 inputs. And logical XOR operator, it gives 1 if one of the bits has 1 value and the other is 0, but both should not be equal. That is, both the input bits should not be the same, 0, 0 or 1, 1. Then the output will be 0. Since it excludes the possibility of both the inputs getting same value, it is called as exclusive OR gate. It is an OR gate. It is taking, if one of the inputs is 1, it is giving 1 as well. But when both of them are there, the OR operation is lost. That's why it excludes, performs the remaining OR operation. Right? So this is how we have 2 bits. When bit 1 is 0, bit 2 is 0. Remember, these bits are not separately available. They are part of the word and data stored in the computer. Each one is extracted separately and the performance of operation is done by these logical gates because they work bitwise. Now, what will be the AND operation? AND operation says only if both the inputs are 1. Now, B1 is 0, B2 is 0, AND should be 0. Then, how about B2? It will also be 0. Next, how about XOR? it will also be 0 because both B1 and B2 are equal and 0. Next, B1 becomes 0 if B1 were 0 and B2 were 1. Then AND gate will be 0 and 1. Since both the inputs are not 1, its output will be 0. How about R? One bit is input, one is 1, other one is B1 is 0 and B2 is 1. OR gate says it will give output if at least one of them is. So B1 is equal to 1. How about XOR? B1 is not equal to 1, B2 is equal to 1. Both of them are not equal to 1, only one of them is 1, so output is 1. Similarly, 1 and 0 will give the combination. AND gate will be 0, OR gate 1, and XOR will be 1. Now lastly, both the bits are 1 and 1. AND gate will give 1 because both the bits are 1. OR gate, however, will give 1 because one of them is 1, both of them are 1. Now, 1 plus 1 is equal to not 2 in logical operation because it operates on bits each, individual bits. There is no carry. Don't get confused. 1 plus 1 is equal to 1 or 1 is equal to 1 only in logical operations. It will not be 1, 0 or 2 or something like that, right? But when you see XOR, since both are 1, they are equal, output will be 0. Now, with the help of numerical example, we'll see. Then we'll go to coding to understand how this is working. So with 4 bytes allocated, largest value for the complementing value will be FFFF in hexadecimal, and that is 4294967295 in decimal, and that will be 3 followed by 10 sevens in octal. This conversion, again I repeat, this conversion you need not bother, just try to understand, right? Next, negation operation. How will it be done? Decimal notation. In decimal notation, I have taken example, numerical example of 25 and 36. Decimal notation, x is 25. And the negation operation will give me this number minus 25. Complement is to be performed. And the answer will be 4294967275. This is what we have seen in the program. How about octal notation? I have taken this number 55474. Now, what is to be done? This 55474 is to be subtracted from 3 all 7s. 7 minus 4, 3, 7 minus 7, 0, 7 minus 4, 3, 7 minus 5, 2, 7 minus 5, 2, and remaining 7s and 3 as it is. So I should get the answer as 3777722203. This is what we got in the program also. Now, hex notation. In hex notation, I had taken 5B3C. We have discussed about it. So what happens? F minus C, 15 minus 12 is 3. F minus 3, 15 minus 3 is 12. C. So last 2 digits should be C3 should be the answer for me. And B is there. So 4 should be, 5 is there, A should be the answer. Let us see the answer. We have got A4, C3 for corresponding to last 4 digits, and remaining things come as it is. It is same as decimal arithmetic. Suppose you have 9999234 minus 134. You will get 9999, last 3 digits 100, as simple as that.